Today we have our third lecture of mathematics about functions. In my previous lecture, we have covered the different section of our chapter in which we have discussed the concept of function, in which we see how the behavior of domain and range, how dependent and independent variables behaves in our functions. We have discussed the different type of function, polynomial function, polynomial function, different trigonometric function, inverse of trigonometric functions, and then explicit, implicit function, even odd function, and other important functions. And we have done some questions from exercise 1.1, and today we will solve the rest of questions of our exercise 1.1. Exercise 1.1, question number 4, part 5. Part is also 4. Now g of x is equals to x minus 3, this. These two straight line represents that this function is a mod function. And when we define a mod function, now solution, now mod function, when we define this mod function, we will write g of x is equals to positive x minus 3. This function is positive if x minus 3 is greater than or equals to 0, which implies that x is equals to 3. And this function is equals to minus x minus 3 if x minus 3 is less than 0. X is okay. Now g of x is equals to mod of x minus 3, and mod function is always defined like this. Means this function, this mod function has two parts. The positive part is x minus 3, and for this part, when we decide the domain, we always say this part is, as I have told you, this part is a positive part, so it always greater than or equals to 0, right? And this is the negative part, and this part is less than 0. When we draw a real line, 0, 1, minus 1, minus 2, minus 3, 1, 2, 3. We know that this this whole part is less than this whole part is less than 0, and this whole part is greater than 0. This is the positive part, positive side, and this is negative side. So we say that this positive side is, for this positive side, this function is greater than or equals to 0. When we take 0 is also in this positive side. Okay. Now, from this concept, we can say the domain of this function is from minus infinity to 3 union close interval. Why I have used this close interval? Because here we have greater than and equal to. Because of this equality, we have to use this close interval. And here we just have this lesser sign. That's why at both sides we have open interval from 3 to infinity. So there is the ending points are same of both interval, minus infinity to 3 and then from 3 to plus infinity. So we can write simply from minus infinity to plus infinity. So this is the domain of our function. And similarly, when we have to find the range of this function, what we do? We simply put x is equals to 3 in our g of x. So what we get? G of 3 is equals to 3 minus 3 is equals to 0. And we, we can say g of x is positive for all other values of x in this domain. So the range of this function is from 0 to infinity. Maybe this question is arises in your mind that why we have taken just the positive part of this domain. The domain is from minus the domain is from minus infinity to plus infinity. This is the domain of function, but we have taken just the positive side of this domain as a range, because as I have told you, we have a mod function. Whenever if I put the function g of x is x minus 3, if you will put any negative number from less than 0, like if I put minus 1, so what we have minus 1 minus 3 and mod function, so we get minus 4. And this mod function always gives you the positive result, that is plus 4. So all negative numbers, if you put any negative number from your domain, you always get the positive result. That's why your range is started from 0 close interval and then 0 to up to plus infinity, because all negative number also gives you the positive result. There is no negative number as a range of your function because of the property of this mod function, which always gives you the positive result. Okay, now we have to draw the table as g of x is equals to x minus 3. For this function, you have to draw the table. So what we do, we take some values from the positive side, some values from the negative side, and 0 is also use as a domain. So what we are doing, 0, 1, 2, 3, then -1, -2, -3. You can take so many other values from positive side as well as from negative side. In fact, these are the values of x, and here we have the corresponding values of g of x. So for when we have x is equals to 0, when x is equals to 0, g of x is equals to 0 minus 3 mod. And as I told you that mod function is always gives you the positive result, so we have plus 3. So for 0 we have g of x plus 3. Then when x is equals to 1, g of x is equals to 1 minus 3 equals to minus 2, and property of mod function, it gives you plus 2. So for x is equals to 1, g of x is equals to plus 2, plus 2. So plus 2. And for similarly you can calculate when x is equals to 2, g of x is equals to 1. When x is 3, g of x is 0. And when x is 0, your answer is 3. And when x is equals to -1, we have calculated for -1 over here. So for x is equals to -1, g of x is equals to 4. And other values you can also calculate by doing the same calculation. And finally, when you draw a proper graph on your graph paper, you can see your graph is 1, 2, 3, 4, -1, -2, -3, -4. This x is representing your x-axis, and this value is for your y-axis. So when you have 0 value, 1, 2, 3, -1, -2, -3. Okay, when x is 0, value is 3. X is 0, y is x-axis is 0, and y-axis is 3. And when x is 1, y-axis is 2. When x is 3, when x is 1, y is 2, and when x is 2, y is 1, and when x is 3, y is 0, and when x is -1, x is 4, x is -1, y-axis is 4. So if you draw this graph, you have this type of, this line should be the straight one, because we have a linear function in, okay, this is the straight line, it should be straight. When you draw it on your proper graph paper, you get the straight line. And for you can check it for the rest of other values. The graph, the complete graph of this function should be look like this. So this is the solution of fourth part of your question number 4. Now question number 4, part 5. G of x is equals to 6x plus 7 for x is less than or equals to minus 2, and 4 minus 3x for minus 2 is less than x. This function is a piecewise function. Here we have two different algebraic equations. This is polynomial of degree 1 and this equation is also a polynomial of degree 1. But for this first polynomial equation, we have x is less than or equals to minus 2 as a domain, and for this equation 4 minus 3x, we have this domain minus 2 is less than x. As we know that simply when we talk about the polynomial functions, we have a domain from minus infinity to plus infinity. Minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4, up to plus infinity, and up to so on from minus infinity. Here I would like to explain this function. So when we have 6x plus 7, here the domain is x is less than minus 2. So we can say that x is less than or equals to minus 2 and greater than minus infinity. So we say that when we take these points of real line which are started from minus 2 to and ends at minus infinity, from minus 2 to minus infinity, and when we take 2 as a part of this interval, we use this square bracket over here, because at this point we have less than or equal sign. When these two signs combine at one end of the interval, we use this square bracket. So we can say from minus infinity to minus 2, we have this equation 6x plus 7. So in a real line, when we talk about this interval minus infinity to minus 2, we use this equation. And for other domain, which points we have, x is greater than minus 2, x is greater than minus 2 and less than plus infinity. So we have an interval, not the point 2 minus 2, but greater than minus 2. We take all those points which are greater than minus 2 to plus infinity. For the rest of these points of a real number, we will use 4 minus 3x. Actually, these two equations are a polynomials, and for polynomials we use the domain from minus infinity to plus infinity. Whole real line is a domain of polynomial function, but here we are using the piecewise function. That why our domain is divided into pieces. So for first piece, which is started from minus infinity to minus 2, we use this first equation, and for the rest of piece, which is started from greater than minus 2 to plus infinity, we will use this second equation of our function. So that's why this function is known as piecewise function, because it divides the domain into pieces, and for both pieces we have two different equations. Now we decide the domains of this function, because in these questions we have to find three different things. The first one is the domain of function, second one is the range of function, and the third thing is we have to find the we have to draw the graph of this function. So the first thing is domain of this function. For domain, what we do for as we know, for the for the polynomials, we have the whole real line is the domain. Whole real line means from minus infinity to plus infinity is the domain of our functions. But here we have two different function, piecewise function. So what we will do, the first domain is started from minus infinity and it ends at minus 2 with a close interval, and the second part of the domain is started from minus 2 to plus infinity with open interval. So simply, because the end points are same, here we have minus 2 and here we also have minus 2. So we can say our interval is started from minus infinity and ends at positive infinity. And similarly, when we talk about the range of this function, what we do, we simply put for this equation, we put the value of x is minus 2. When we use minus 2 at the place of this x, what we get? 6 multiplied by minus 2 plus 7 is equals to minus 5. So our first range is from minus infinity to minus 5. And our second range is, this is the second equation. So similarly, as we have find the domain for first equation, we will find the domain, sorry, not domain, range. As we find the range for first equation, similarly we find the range for second equation. And in second equation again we put minus 2 at the place of this x. So what we get? 4 minus 3 multiplied by minus 2, 4 plus 6, and that is equals to 10. So we have from minus infinity to, and this is the subset of as minus infinity minus 5 is a subset of minus infinity to 10. We can say the range of this function is from minus infinity to 10. This is the range of our function. And the last part of this question, we have to draw the graph of the function. And when we use such type of function in which we have two different equation for the same function, we have to draw two different tables. For graph, we have to draw two different tables. The first graph is for the equation when g of x is equals to, 6x plus 7, and here we have the domain is x is less than or equals to minus 2. So when we plot uh, when we give different points to x, we get the corresponding values for g of x. So when we have to take all those values which are less than minus 2, less than or equals to minus 2. So first value must be minus 2, second value is minus 3, then minus 4, and so on. At this point, when x is equals to minus 1, minus 2, g of x is equals to, we can calculate here, x is equals to minus 2, g of x is equals to 6 into minus 2 plus 7 minus 12 plus 7 is equals to minus 5. And for x is equals to minus 3, g of x is equals to g of minus 3 means 6 of minus 3 plus 7 is equals to minus 18 plus 7 is equals to minus 11. So here we have minus 5, minus 11 and so on. And these are the points for the first graph. And when we draw the second graph, here we have for second graph g of x is equals to the second g of x is equals to the second equation, which is equals to 4 minus 3x. X is greater than minus 2. And for x, if we give simple values minus 1.99, minus 1012, you can calculate g of x. When x is equals to minus 1.99, g of x is equals to 9.97. For minus 1, g of x is equals to 7. For 0, g of x is equals to 4. For 1, g of x is equals to 1. And for 2, g of x is equals to minus 2. And for both these equation, you can plot a graph. Take different values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Similarly, minus 1, minus 2, minus 3, minus 4 and minus 5, minus 6, 1, 2, 3, 5, minus 1, minus 2, minus 3, minus 4 and minus 5, 0. For the first graph, when we have the value of x is equals to minus 2, g of x is minus 5. For minus 2, g of x is minus 5. And when x is equals to minus 3, g of x is equals to minus 11. So minus 6, minus 7, minus 8, minus 9, minus 10 and minus 11. When x is minus 3, g of x is minus 11. So this is the first graph of our function when we have g of x is equals to 6x plus 7. For this equation, we have this graph. And for second equation, which values we have? For 0, we have plus 4. For 0, we have plus 4. And for 1, we have for 1, we have plus 1, and then for okay, when we have 2, when x is equals to 2, this 2, g of x is minus 2. When x is equals to 2, g of x is equals to minus 2. And for 1, when x is equals to minus 1, g of x is equals to 7. G of x is equals to 7. X is equals to minus 1, g of x is equals to 7, and when x is equals to minus 1.99, which is very near to minus 2, g of x is equals to almost near to 10, 9.99 here. Okay. The first value is for minus 1.99, g of x is equals to 9.99. When x is equals to minus 1, g of x is equals to 7. When x is 0, g of x is 4. This is the value. G of x is 4, and when x is equals to 1, g of x is equals to 1, and when x is equals to 2, g of x is equals to minus 2. So when we plot it, this is not a straight line, but when you will draw it on a proper graph paper, you will see the graph must be a straight line, because we have a equation of a straight line. So this is the graph of this piecewise function. This straight line is for the equation, this straight line is for the equation 4 minus 2x, 4 minus 3x, sorry, 4 minus 3x is, this straight line is for the equation for when g of x is equals to 4 minus 3x, and this is the graph when g of x is equals to 6x plus 7, and these are two lines which are not connected with each other. That's why this is the pieces of a graph. That's why this function is also known as the piecewise function. Now this is the